Good morning, my name is Achraf bin Chronicles. I am pleased to present to you my article entitled Evidence Theory-Based Combination of Frequent Chronicle for Failure Prediction, realized in the National Institute of Science of Strasbourg, France, to obtain the Research Master in Web Intelligence from the Higher School of Digital Economy of Manouba, Tunisia, under the supervision of Dr. Ahmed Samet and Dr. Mohamed Tobji. The word saw for Industrial Revolution. The last one is the Industrial Cut 4.0. The revolution is based on the new technology which are characterized by automating and information exchange between the machine and the process, like the Internet of Things, big data, and artificial intelligence. This technology has as many objectives to improve quality and industrial production. This intelligent system can detect the future failure, which allows the quick and efficient intervention in the right moment. All that take us arrives to talk about the predictive maintenance, which can allow us analyzing not only the sequence of events but also the time concept. This concept have an important role in the prediction of failure in the right moment. For that, we will need a specific technique to analyze the sequence. Data mining, particularly pattern mining, is techniques allows the discovering of the failure sequence. The function of this technique is to analyze the frequent sequence behavior that caused the failure. The sequence is composed of successive events, time-stamped and labelized. The chronicle is one of the wealthiest patterns of information which give note and details of events, succession, and the time between them. What seems useful to analyze the frequent sequence behavior that caused the failure. The chronicle is a graphic presentation which its top are the event and the link is the time between them. Let's suppose it now that we have a new sequence and we want to determine if we will generate a failure or not. If it is the case, we will know exactly which time the failure was provoked, because we want to know if it is the failure, where it will be. Some of the frequent chronicles extract can be failure or normal function. So we have a multiple source of uncertain information, and this makes it difficult to classify new sequence. For that, we appeal to uncertain framework named the evidence theory. This theory enables us to model the uncertain information. Thus, it enables to combine the source of information to make a decision and classify the new sequence. The theory of the evidence theory is characterized by three characteristics. The first character is the frame of discernment, which is the set of hypothesis solution for given problem. Also, it allows to build the set of veracity to evaluate the power of all the hypotheses. In our example, in our work, we have the hypothesis for failure in the sequence or a normal function. The second characters for the theory of evidence is the basic belief assignment. It is the mapping of elements power in our set and it between 0 and 1, and the sum of power is equal to 1. And it is calculated for each source of information. And if in our example there is many chronicles that make failure, so we calculate the mass function m for this chronicle. And this mass function will describe the distribution of this source, failure or normal, for each class of the problem. Third character is the Dempster rule combination, and it allows to combine the mass function already established compared to every initial information source. The evidence theory allows classifying a new sequence, the hypothesis which has the greatest value is the result of classification, and this will be in the final decision phase. In the final phase, the pygnistic transformation consists in distributing equi-probably the mass of proposition A on its sub-hypothesis. The hypothesis which has the greatest value, like what we say, is the result of classification. We pass now to describe our approach. Our approach is based on two initial parts. The first one consists to extract the frequent chronicle from the set of sequence, regardless of the failure sequence or the normal sequence. Then, for a new, the second part of our approach, or the second steps, is when we have a new sequence and we want to determine to classify this new sequence. It will be failure or normal function. So we will match this new sequence with the set of frequent chronicle extracted for our set of sequence. The matching is in order to the events and the time. When we have the matching is how many the chronicle describe this new sequence. When C cover the sequence S, if and only if the events represented by the chronicle belong to the sequence, as well as the time interval between these events in the sequence belong to the temporal constraint extracted by the chronicle. The next step in this second step is the modeling of basic belief assignment. In this step, assuming a chronicle of failure or normal chronicle in a set of chronicle that match the new sequence and that cover a sequence, the new sequence S, we model the BBA of mass of function of this chronicle in our set as follow. The mass function of the hypothesis failure or normal equal to support of the chronicle in this set. For example, if we have this chronicle in our set and the support of the frequent chronicle is 2 for 6, so the support of this chronicle is 2, and this chronicle is normal or failure, so the function of the opposite of this chronicle, if the first is failure, so the inverse of or the mass function of the inverse of this chronicle equal 0, and the third value is 1 minus the value of this support of this chronicle. After the modeling with the BBA, we pass to the fusion of all these mass function that combine all the elementary mass function of the chronicle CE that cover our sequence S using the Dempster rule of combination, and it is defined with the conjunctive rules. And finally, the decision is obtained by returning the hypothesis that maximize the pessimistic probability when we calculate the probability of all the hypotheses after the fusion, and the result, if it is failure, we will calculate the time of this failure, which will be the interval of time of frequent chronicle that design the failure. Let's pass now to the section experimentation. We did tested our approach on two types of data, synthetic data and real data. For the synthetic data, we have developed our generator of data in changing many variables and parameters. Number of sequence, size of sequence, and the number of events in the sequence. In addition, we injected in the sequence 5% of failure sequence. Also, the size of failure models injected is equal to 40% of the length of sequence. This injection is to make models of failure in normal sequence, and the generating of sequence is randomly. So we have in our generator the sequence that we have failure and other sequence that we have normal function. For the real data we used SECOM that contains 1567 events timestamp and generate one for normal function and -1 for failure function. The evaluation of our approach is divided in two parts. The first part is the performance, and where we tested the execution time and the consumption memory. And the second part is the quality, and we tested the recall and the precision. The figures show the execution time of our fusion of Chronicle for production according to the number of sequence and the vocabulary size. The execution time increases when the number of sequence and their size increase. Indeed, when number and size of sequence are large, the number of extracted frequent chronicle increase accordingly. The Dempster rule of the combination is the most consuming part of our approach. The more we find matching chronicle, the more we model and combine BBA. For the memory, the amount of memory used according to the sequence number variation. For our algorithm fusion of chronicle prediction, to use of memory increases when the number of covering chronicle increase, especially because of the operation of combination that use matrix structure within the evidence theory of mass function. For the quality experiments, the experiments that we do show that our algorithm is out performance or the classifier we considered in the comparison. Like recall, we have 0.78, precision 0.81, and F measure 0.79. It is our performance of the other algorithm. To conclude, in this paper we are interested in prediction of failure as well as their time of occurrence in the context of predictive maintenance of industrial machine. We predict the failure as well as the time, and we use the frequent chronicle mining and the evidence theory to take decision of the state of the new sequence. And our approach is satisfactory in terms of performance and quality. For perspective, we improving prediction of the occurrence time, more precise by predicting the most probable instance of occurrence. And thank you.